In this problem, we're given the graph of f of x and g of x. In fact, it says the graph above shows the function f of x. The graph below shows the function, the graph of g of x. And they tell us that g of x was a transformation of f of x. And they tell us how it was found. G of x is the same thing as f of x, except they multiplied the equation on the outside by some number a. So what that does is potentially two things. If a was positive, it would not do an x-axis reflection, but if a is negative, it would do an x-axis reflection, and that's what you're seeing here. It looks like g is the upside down version of f. The only way to get that to happen is to do an x-axis reflection, and to get an x-axis reflection, you'd have to have a negative outside here. So a is definitely going to be negative. But it looks more like they also stretched it. So not only did they flip it about the x-axis, it looks like the graph of g is bigger than the graph of f. So the question is, how much did they stretch it? So what I do is I hone in on a single point. In this case, I'll look at the high point, which has coordinates 2, 2, and I ask myself, what happened to that point? Well, when they flipped it upside down, it would become the point 2, negative 2. But if you look at it, it actually became 2, negative 4 right here. So it looks like what they did is leave the x value alone, but what did they do to the output? In fact, notice that f of x is the notation for the output of f. That would be this guy right here. And g of x is the notation for the output of g. That would be this guy right here. So they're telling you that they got the output of g by taking the output of f and multiplying by some number a. So what did they multiply the output by to get from point A to point B? So it's clear to me that you multiply this number by negative 2 to get this one, but if you want, you could set up an equation. The output of f was 2, and they multiplied it by some number a on the outside, and what they got is the output of g is now negative 4. So think of it as you have this equation, negative 4 equals, instead of a times 2, think of it as 2 times a. And you'd solve that equation by dividing by 2. Since the 2 is being multiplied by a, we would divide both sides by 2. And if I divided by both sides by 2, these would simplify out. 2 divided by 2 is 1. So you have 1 times a, which is just a. And then negative 4 divided by 2 is negative 2. So again, the negative here is obvious in the fact that they reflected the graph about the x-axis. That's why it's an upside down version of this. The fact that they multiply by 2 is evident by the fact that it used to have a height of 2. Its high point had a y value of 2, and the low point has a y value of negative 4. So they had to have doubled the y value in addition to flipping it upside down.